All right, strap yourselves in, because today we're tackling a question that seems simple at first, but trust me, it gets pretty complex. How high is the sky? And I know you want the real answer, right? Not just some general idea, but the actual boundary where Earth's atmosphere fades out when we hit outer space. We're talking about the invisible line where the sky as we know it becomes the cosmos.
Yeah, it's quite a journey when you think about it. And it all begins right here with us on the ground.
Exactly. So let's kick things off with something we all know. Human height. On average, men are about 1.7 meters tall globally, and women are around 1.6 meters. But here's the interesting part. Some of the tallest folks on the planet come from countries like Latvia, the Netherlands, even Sweden. Ever wonder why that is?
Well, our environment actually plays a huge role in how we develop physically. There's this fascinating concept called Bergmann's rule. It suggests that in colder places, animals, and yes, that includes us, tend to be bigger. It's all about conserving heat. Think about it, polar bears up in the Arctic are massive compared to those adorable little sun bears you find in tropical rainforests. A larger body helps them stay warm in those freezing temperatures.
So it's not just genes, it's also about how we adapt to the environment.
Yeah.
Makes you wonder, what other environmental things have shaped how humans evolved and adapted around the world, right?
It really does. But while we're on the topic of height, let's not forget those individuals who really push the boundaries of how tall humans can be. Robert Wadlow, the tallest man ever recorded, was a towering 2.72 meters tall. That's taller than most doorways.
It's incredible to think about. And speaking of pushing limits, it's amazing how high we can physically propel ourselves. The current high jump record is an unbelievable 2.45 meters. Really shows the power of the human body.
Absolutely. And if you thought that was impressive, get this. The highest vertical reach ever recorded was a whopping 3.83 meters. And get this, it was by a volleyball player. Not even a basketball player.
Now imagine taking that leap to a whole new level. Literally. Have you ever heard of pool diving?
Oh man, that's not for the faint of heart. These folks are launching themselves from platforms over 11 meters high, which is taller than a 3-story building, and landing in a pool that's barely a foot deep.
Okay, that sounds terrifying, but also kind of thrilling. What goes through someone's mind standing up there ready to jump?
Well, I think it takes a certain mix of courage, definitely skill, and maybe just a little bit of daredevil spirit. One diver, known for these crazy jumps, once said, "The pain, it only lasts a minute, but the glory, that lasts forever."
All right, I get the sentiment, but I think I'll stick to watching from the ground. Now let's switch gears and talk about some natural giants, ones that dwarf even our tallest buildings.
Ah, you're talking about dinosaurs. The Argentinosaurus, the largest dinosaur we've ever found, is thought to have been over 35 meters tall. That's like a 10-story building walking around.
It's hard to even picture something that big.
Right.
And while we're on giants, can't forget about the amazing trees that rule our forests. The tallest one alive today is called Hyperion. This thing stretches a mind-blowing 115.85 meters high. That's even taller than the Statue of Liberty. And they think it's over 700 years old.
It's a real testament to how powerful nature is. And, the exact spot where Hyperion is, it's kept secret to protect it.
I get it. It's like a hidden treasure of the natural world. But let's jump from those ancient giants to some modern marvels. Skyscrapers. They're pushing the limits of how high we can build. And they're a testament to human ingenuity.
Oh, for sure. Cities are reaching for the sky in amazing ways. The Merdeka 118 in Kuala Lumpur, that one stands at a breathtaking 678 meters tall. And the International Commerce Center in Hong Kong soars at 484 meters.
And then there's the classic Taipei 101, hitting 509 meters. And of course the Shanghai Tower, a majestic 632 meters. Each one is a marvel of architecture, but even these massive structures are dwarfed by the current champ.
The Burj Khalifa in Dubai, no question. This thing is a staggering 828 meters tall. It pierces right through the clouds, redefines what's even possible in architecture. It's a symbol of global teamwork, too. American designers, South Korean engineers, and a Chinese construction crew all came together to build it.
A true global achievement. But, Dubai's ambitions don't stop there. They've got plans for something called the Dubai City Tower. If they actually build it, it'll be a mind-blowing 2,400 meters tall. Almost 3 times the height of the Burj Khalifa.
That's enormous. And with a structure that massive, they're really focusing on sustainable design, thinking about incorporating renewable energy, things like solar and wind power.
It's fascinating to think about the future of architecture and how sustainability will play a role. And while we're on the topic of ambitious projects, we can't forget the Tokyo Babel Tower. Sadly, it was never built.
Right, the one that was supposed to be a mind-boggling 10,000 meters tall. Imagine that. A building taller than Mount Everest. The idea was to house all of Tokyo's residents in it. Now, it turned out to be way too difficult to construct, but it's still an incredible concept, isn't it? Makes you think about the possibilities and maybe the limits of human ambition.
It really does. It makes you think about how we plan our cities and how we build sustainably. But for now, let's shift gears and come back down to Earth. Literally. Let's talk about some natural heights that have always fascinated people. Mountains. Those majestic peaks that pierce the sky.
Absolutely. Let's start with something a bit closer to home. Hong Kong's Tai Mo Shan at 957 meters. It's got breathtaking views of the area, but for a real high-altitude experience, gotta mention La Paz, the highest capital city in the world, it sits at a breathtaking 3,640 meters above sea level.
I've heard it can be pretty tough living at such high altitudes because the air is so thin.
Oh, you're absolutely right. Less oxygen up there can lead to altitude sickness, makes it hard to breathe, and causes other changes in your body. But the people of La Paz, and there are over 800,000 of them, they've adapted incredibly well. Shows you how resilient the human body is.
Amazing. So from La Paz, let's take a quick visual trip to some other iconic East Asian peaks. There's Mount Fuji in Japan, standing proud at 3,776 meters. Then you got Yushan in Taiwan, reaching 3,952 meters.
And don't forget about Mount Kinabalu over in Malaysia. That one towers at an impressive 4,095 meters. These mountains aren't just visually stunning, they also hold deep cultural and spiritual significance for the people who live near them.
And as we keep climbing, we get to the Tibetan Plateau, which has an average elevation of 4,500 meters. It's one of the highest and largest plateaus anywhere, and amazingly, people have been living there for thousands of years.
A true testament to human adaptability. And speaking of incredible feats of engineering at high altitudes, did you know the highest railway station in the world is on the Tibetan Plateau? It's called Tengala Station, and it sits at a dizzying 5,068 meters above sea level.
Wow. Passengers going through that station must really feel like they're on top of the world. Building and maintaining a railway at that altitude, it's mind-blowing.
It really is a true engineering marvel. But of course, when we talk about reaching for the sky, we can't forget about the ultimate challenge, Mount Everest.
Mount Everest, the king of all mountains, standing at a majestic 8,848 meters. It represents the power of nature and the incredible human drive to conquer seemingly impossible challenges.
It's interesting to think that while it takes immense skill and endurance to climb Everest, something as simple as a hydrogen balloon, if you let it go, could technically reach those kinds of heights. Of course, the balloon wouldn't survive the trip. It would burst because of the low air pressure.
That's a great way to picture just how high Everest really is. And as we approach the 10,000-meter mark, we're entering the domain of commercial airplanes, cruising high above the clouds and all the weather down below.
It's amazing the technology that lets us travel at those heights and speeds. Speaking of incredible stories from the world of aviation, have you heard about Vesna Vulovic, the flight attendant who survived a 10,000-meter fall without a parachute?
Wait, seriously, that sounds impossible. How could anyone survive a fall from that high up?
It's a story that still blows people's minds. She was on a plane that unfortunately exploded because of a bomb, and she was the only one who survived. They think a bunch of things contributed to her surviving. Landing in a snowy, wooded area and where she was positioned in the plane when it happened.
Sounds like a mix of incredible luck and pure resilience.
It really does. But it also makes you think about the mental and emotional impact of going through something so traumatic. She had survivor's guilt for years afterwards. It's a reminder that even when people survive extraordinary things, there can be lasting emotional scars.
A powerful reminder that our experiences, even the ones that seem unbelievable, shape who we are. So, as we keep going up beyond the heights humans usually experience, we have to start talking about the science of the sky itself. It's more than just what we see above us. It's about the different layers of atmosphere that surround our planet.
Exactly. To really understand how high the sky is, we need to look at these layers, each with its own unique features.
So let's start with the troposphere. It goes from the Earth's surface up to about 11,000 meters. This is where all our weather happens. Clouds forming, rain, wind, the whole shebang.
Speaking of clouds, ever wondered how something that weighs tons can just float up there?
It's something I've always wondered about.
It all comes down to density. Clouds are made of tiny water droplets, or ice crystals, spread out over a huge area, and they're actually less dense than the air around them. That's what lets them float. Kind of like a boat on water.
That makes sense. So what's up there beyond the troposphere, where the weather we know just stops?
Above the troposphere, you've got the stratosphere. It stretches from about 11,000 to 50,000 meters. And this is where the ozone layer is, that super important shield that protects us from harmful UV radiation from the sun.
Like Earth's built-in sunscreen.
Exactly. And the stratosphere is also where some of the craziest skydiving feats have happened. Back in 2014, Alan Eustace, a Google exec, jumped from a crazy 41,419 meters. He actually reached speeds faster than the speed of sound during his fall.
Wow, that's not just breaking the sound barrier, that's pushing the limits of what humans can do. Falling faster than sound. Must have been an unbelievable experience.
Like traveling through time.
Yeah.
And then above the stratosphere, you've got the mesosphere. Goes from about 50,000 to 80,000 meters. This layer is a bit of a mystery because it's too high for airplanes and too low for satellites. The air up there is crazy thin, making it tough to study, like a no man's land in our atmosphere.
Sounds otherworldly. So as we keep climbing higher, are we finally getting close to that edge of the sky? That point where Earth's atmosphere ends and space begins?
We're getting there. And as we approach that boundary, the whole idea of what the sky is, it gets even more interesting.
This is where things get really exciting. I can't wait to cross that threshold and see what's on the other side. But let's save that for the next part of our journey. Stay tuned as we continue to explore how high the sky really is. All right, welcome back to our Sky High Deep Dive. We're about to reach that boundary, that edge of space, and I'm ready for it.
Buckle up, because we're approaching a major milestone, the Karman Line. This is the spot, about 100,000 meters above Earth, that's officially recognized as the edge of our atmosphere, where outer space begins.
So that's where the sky as we know it ends. What makes this line so special, though? What separates it from all those atmospheric layers we talked about?
It all comes down to how things fly. Below the Karman Line, airplanes, they use their wings and engines to create lift. The air is thick enough down there to support regular flight. But above this line, the air thins out so much that it's pretty much impossible for aircraft to stay up. To get that high, you got to hit something called orbital velocity.
Orbital velocity. That sounds pretty intense. To be honest, not totally sure what it means.
Basically, it means going so fast that you're always falling towards Earth, but you're moving forward so quickly that you keep missing the planet. It's like falling but going sideways so fast you just keep going around. That's what orbiting is.
So you're always falling but never hitting the ground because you're zipping around sideways. Mind blown. So the Karman Line is that point where normal flying turns into space travel.
Exactly. And when you see those amazing pictures of Earth from space, with that thin blue line around our planet, that's basically the Karman Line, where our atmosphere meets the blackness of space.
It's almost poetic, isn't it? This thin blue layer keeping us alive down here, meeting the vastness of space. But what's happening in this region? Is it completely empty up there?
Not totally. This is actually where most meteors burn up when they enter Earth's atmosphere. They're traveling crazy fast, and when they hit those thin air molecules at this altitude, the friction heats them up, makes them glow.
Ah, so that's what creates those shooting stars. I always thought meteors were huge, like massive rocks hurtling through space.
That's a pretty common thought, but a lot of meteors are actually tiny. Some are just the size of a grain of sand or a small pebble. But it's the speed, sometimes tens of thousands of kilometers per hour, that makes that bright streak of light we see from Earth.
Makes those meteor showers even more amazing. Knowing those flashes are coming from something so small really shows you appearances can be deceiving. And speaking of awesome things we see in the sky, what about auroras? They've always been a bit mysterious to me.
The aurora borealis and aurora australis, they're definitely one of nature's most spectacular shows. You get these dazzling displays when charged particles from the sun carried by solar wind interact with the gases in Earth's upper atmosphere.
So it's like a cosmic dance between the sun and Earth's atmosphere.
You got it. And did you know that the colors of the aurora actually depend on how high up these interactions happen?
Now that's something I've always wondered about.
So those lower auroras, around 100,000 meters, they tend to be purple or pink. Then a little higher, between 100,000 and 200,000 meters, you get the more common green and blue auroras. And those vibrant red auroras, the really showstoppers, those happen at the highest altitudes, something like 200,000 to 500,000 meters.
It's like a giant atmospheric canvas with different colors painted at different heights. Next time I see an aurora, I'll definitely be looking for those color variations. But as amazing as it is up here, I'm ready to keep climbing. What's beyond the Karman Line? What's past the meteors and auroras?
Well, as we keep going into that super thin air and intense solar radiation, we run into the thermosphere. This layer goes from roughly 80,000 to 800,000 meters, and it's a pretty wild place.
Thermosphere. The name makes it sound like it's super hot up there.
You're not wrong. The temperatures in the thermosphere can actually reach thousands of degrees Celsius. But here's the thing. Even though it's that hot, it wouldn't feel hot if we were up there.
Wait, thousands of degrees but not feel hot. How does that even work?
It's all because the air in the thermosphere is incredibly thin. The air molecules are so spread out that they barely collide with each other. So even though each molecule has a lot of energy, which we measure as high temperature, there wouldn't be enough of them hitting you to transfer much heat.
So it's like being in a hot oven, but there's barely anything in the oven to actually make you feel the heat. That's crazy.
It really highlights the difference between heat and temperature. They're not the same thing. Heat is about transferring energy, and temperature is about the average energy of molecules. In the thermosphere, you've got high temperature but low heat transfer. But let's keep going. We're almost at our final destination.
Lead the way. Where are we headed?
To the International Space Station, or ISS. It's this incredible feat of engineering orbiting at around 408,000 meters. It's a laboratory, an observation platform, and a testament to international collaboration. Astronauts from all over the world go there to do groundbreaking research and take those amazing pictures of Earth.
The ISS is like this symbol of human ingenuity, our drive to explore. Seeing those pictures taken from up there, they're breathtaking. I have to ask, though, how fast is the ISS actually traveling?
Get ready, because the ISS is whipping around Earth at a speed of roughly 7.7 kilometers per second. That's fast enough to circle the planet every 90 minutes.
Wow. Amazing to think that humans built something that can go that fast while orbiting Earth.
A testament to human brilliance and the desire to push our boundaries. And here we are, at the end of our journey, looking back at Earth from the ISS. Makes you think about all the different scales we've encountered.
It really has been an amazing trip, from standing on the ground to being up here with the stars. We started with human height and ended up talking about a structure that's circling the planet at thousands of kilometers per second. Shows you just how many different scales exist, from tiny things to the cosmos itself.
And it makes you realize how much there is to discover beyond what we see every day. Who would have thought that a cloud, something so ordinary, is actually a marvel of physics, floating up there because of its density?
Exactly. Yeah. And while humans have done some pretty incredible things, like building skyscrapers in the ISS, there's still so much out there to explore. It makes you realize that the sky, both literally and metaphorically, is truly the limit. That idea of endless possibilities, that's something we can all find inspiring, I think.
I agree. So next time you look up at the sky, don't just see a blue expanse. See it as a symbol of what humans can achieve, a reminder that we can do amazing things when we aim high and aren't afraid to explore the unknown.
That's a beautiful thought. And as we learned today, exploring doesn't always mean going to space. Sometimes it's about looking at the things we see every day with a fresh perspective and asking those questions that lead us to new discoveries. Thanks for joining us on this deep dive into how high the sky really is. We hope you'll keep looking up and keep asking questions about the world around you. Until next time.
Man, what a journey that was. From standing on solid ground, looking up at that blue sky, to all the way out there at the International Space Station. Amazing to think about how much ground we covered, literally. It really changes how you see things, doesn't it? We started with something as basic as human height and ended up talking about this structure that's orbiting the planet at insane speeds. Really puts things in perspective, all the different scales that exist in the universe.
And it just shows you how much there is to learn and discover beyond what we see every day. Like, who knew that clouds, those fluffy things we see all the time, are actually these incredible examples of physics just floating up there because of their density.
Exactly. And it's amazing what humans have been able to accomplish pushing the limits with skyscrapers and the International Space Station, but there's still so much more out there waiting to be explored.
It makes you realize the sky really isn't the limit, is it? Whether you think about it literally or figuratively, that feeling of endless possibility, I think that's something we can all learn from.
Absolutely. So the next time you're outside and you look up at the sky, don't just see an empty blue space. See it as a symbol of what humans can achieve. A reminder that we can do amazing things when we set big goals and push ourselves to explore the unknown.
I love that. And as we've learned today, exploring the unknown doesn't always mean going to space. Sometimes it's about looking at everyday things in a new way, asking those what-if questions that lead to new discoveries right here on Earth. So thanks for joining us on this incredible deep dive into how high the sky really is. We hope you'll keep looking up and keep those curious minds working. Until next time.